For 15 volumes, this quest looked outward and inward at the extremes, the first instant of time, the interior of a black hole, the nearest mystery of mind. And in the 16th, I finally turned the telescope around and picked up the thing in my hand. The chair that holds my weight, the glass of water on the chart table, the chip of silicon in the machine I write on. This is a book about the physics of the tangible, and I wrote it to correct a prejudice I once shared. There is a hierarchy of prestige in physics, and everyone in the profession knows it while denying it exists. Condensed matter sits low on that ladder, filed under the useful rather than the profound. That verdict is not a little wrong. It is wrong in its foundations, and the 20th century proved it wrong in the most rigorous way available, by discovering, inside a lump of ordinary matter, whole new laws that no amount of knowing the parts could have predicted. The organizing idea is Philip Anderson's, and I put his 1972 essay on the chart table because everything in the book descends from it. More is different. Anderson granted the reductionist everything. The laws are the laws. No lump of matter violates the Schrödinger equation, and then showed that this concession settles almost nothing, because assembling 10 to the 23rd particles and packing them close does not merely complicate the physics, it writes genuinely new and equally fundamental laws at the higher scale. I spent real effort making emergence precise rather than mystical, because it is exactly the kind of word a juror should distrust on sight. In this book, it never means something arriving from nowhere. It means rigidity, conductivity, magnetism, superconductivity, collective behaviors as exact as anything in the parts list, yet invisible in any single atom. That distinction between emergence as a real and gradable phenomenon and emergence as a shrug is the spine of the whole volume. I graded as I went by the tiers this series has used since its first page. The established, which in this field is one of the tallest columns in all of physics. The contested but serious, where working scientists actively fight. The speculative bridge, plausible in principle and not yet demonstrated, and the claims the evidence simply will not bear. And behind the grades stands the stance I have named in every volume. The juror, not the advocate, who does not decide in advance which side to believe. It matters here because the field carries, on one side of the table, the transistor and band theory and BCS, and on the other, a wound as deep as any in science. The book is built in 7 movements. The first sets out the great idea and the quantum foundation beneath it, why solids are quantum machines at all, resting on the Pauli principle that keeps electrons apart and gives matter its bulk, and on the Fermi sea, whose waterline governs nearly everything that follows. I trace Drude's beautiful broken model of the metal and Sommerfeld's elegant repair because the route physics actually took teaches more than the finished result. Then I lay the crystal architecture, the lattice, the fixed catalog of symmetries a periodic solid may possess, the X-ray method by which the Braggs made the invisible grid visible, and my favorite cautionary tale, the forbidden 5-fold symmetry that Dan Shechtman found in a quasi-crystal and was mocked for until the mockers were wrong. It is precisely the kind of case this series was built to reason about, and it cuts against the reflex to protect consensus at all costs. The second movement is the band theory that built the modern age. Bloch's theorem explains why electrons glide through a periodic lattice as waves rather than scattering off every atom, and from that single stroke fall metals, insulators, and semiconductors, the difference between them reduced to where the filled bands stop. This is as settled as physics gets, and it is not close. The semiconductor revolution, the transistor, the entire electronic world are its cashed check. I credit them in full. Phonons, the quantized sound of the lattice, close the movement and set up the ballet to come. The third takes up broken symmetry and order, the field's great mechanism, magnetism arising from spinning electrons falling into collective alignment, phase transitions, and the deep universality of critical phenomena, where utterly different materials obey the same numbers near their critical points. And then the frictionless states, superfluidity, helium flowing without viscosity, and Bose-Einstein condensation, a genuinely new state of matter in which a cloud of atoms surrenders its individuality and moves as one quantum thing. The fourth movement is the crown jewel, superconductivity, and I gave it 4 chapters because it earns them. Zero resistance was a discovery before it was a theory, an experimental scandal that waited nearly half a century for explanation. The BCS theory supplied it. Electrons, which should repel, are coaxed by the lattice into Cooper pairs that condense into a single coherent quantum state, and I mark the conventional case firmly established. Then comes the wound. High-temperature superconductivity has been attacked for 40 years by an army of brilliant people with every tool physics owns, and the mechanism remains genuinely unsolved, not mysterious in a poetic sense, but open, a debt the field has not paid. And I devote a full chapter to grading the room temperature dream honestly, which meant declining LK99 and its kind not out of cynicism, but out of method, while keeping the door open to what real evidence might one day walk through. The fifth movement is the topological revolution, the most beautiful surprise of my professional lifetime. The quantum Hall effect showed conductance quantized to a precision rivaling the finest measurements in physics, and the reason turned out to be topology, a property of the electronic state as robust as the number of holes in a coffee cup, indifferent to the material's dirt and detail. From it descend topological insulators, which conduct only along their edges by protected states that disorder cannot destroy, and graphene, the two-dimensional carbon sheet whose electrons behave as if massless. I close the movement on quasi-particles, the emergent particle-like excitations that are the working reality of the field, entities that exist only inside matter and yet are as real for all practical purposes as anything in the vacuum. The sixth movement walks to the useful and the unfinished frontier, disorder and Anderson localization, where enough randomness freezes electrons in place, strongly correlated electrons, where the clean single particle picture that built the age simply fails, and no replacement yet commands the field, soft matter, and the physics of the everyday, the glasses and polymers and liquid crystals, and the quantum materials from which the coming technologies, quantum computers among them, may or may not be built, graded with the same caution I brought to every promise. The final movement is the verdict. I open the reductionism debate properly and settle it as Anderson did. Reductionism runs downward and is true, but the constructionist fallacy, the belief that knowing the parts lets you reconstruct the whole, runs upward and is false. Then I ask what condensed matter says about the cosmos, and the answer is the quiet argument of the entire quest. The pattern the field establishes on solids is the pattern that runs the whole way up. Life is emergence. Mind, I have argued, is emergence. The universe at every scale writes new laws from old parts. This is why the physics of the chair is not the humble cousin of the physics of the cosmos, but its indispensable partner. And there is a homecoming I did not force. This is the science of what electricity does inside matter, the literal subject at last of a thread that ran through 15 prior books, which is exactly why I owe it the razor on its overreach, drawn here with the same edge I drew against every grand electric claim before. I did not close on unbroken triumph, because that would be the advocate talking. The specter in this field is that its deepest open problem, high TC, has resisted the full weight of modern physics for 4 decades, and honesty requires naming that. But an open problem is a debt, not a bankruptcy. What I carry away from this volume is a corrected astonishment that inside a chip of silicon and a chip of quartz, there is a universe of law as deep as anything in the sky that more really is different, and that the tallest column of established science I have yet audited stands beside one of its most honest wounds. Naming both without flinching at either is the only posture worthy of the matter in our hands.